All right, so welcome to lesson 4.1.3. We're going to do comparing data sets. So for this section, we're going to construct a box and whisker plot of each given data set and include any outliers. Calculate the most appropriate measure of center and spread for each data set based on the data distribution. So the data are all of that. I'm not really going to read it. However, let's make sure that they're in order from smallest to biggest so that we can start constructing our box and whisker plot. So taking a look here, it does look like our numbers are in order from smallest to biggest. So that way we can actually start writing out our 5-number summary. Remember, the 5-number summary includes the minimum, the Q1, the first quartile, the median, the Q3, the third quartile, and the maximum. All right, let's start off with the minimum and maximum, the easiest ones. They are 5 and 95. Now to do the median. So median is next. We do the median by crossing off the numbers until we get to the middle number. So I'm going to cross off, or underline in this case, the edge pieces. Cross off and underline again the edge pieces. Get rid of 3 of the edge pieces, get rid of another set of edge pieces, and keep going. And then we found our median is 65. All right, now that we found our median, we have our 2 halves. So I'm going to ignore that 65. The 65 is not part of the 2 halves. Let's focus on the first half, which goes from 5 until 63. I'm going to cross off numbers here until I get to the middle. So I'm going to cross off the top, and then I'm going to cross off those pieces, and then cross off those, and we find that our middle of this first half is 50. Therefore, our Q1 is 50. Now for the second half, which is right over here, let's cross off the edges. And again, until we get to the absolute middle, which is 78. So that is our Q3. Now we have our 5-number summary. I'm going to go ahead and draw a line on top of each of those numbers. A line on top of our minimum, a line on top of our Q1, a line on top of our median, a line on top of our Q3, our third quartile. That would be somewhere around here, just estimate it, eyeball it, and our maximum. Okay, with the middle 3 lines, you can draw a box. And then with the edge ones, you can connect them with whiskers. Therefore, we made a box and whisker plot. All right, so here's my box and whisker plot. And we need to also include outliers. So to figure out our outliers, we want to calculate our lower fence and our upper fence. I'm going to write that out over here. Okay, so to get the lower fence and upper fence, let me write out their formulas. Hopefully they look familiar to you because we've done them before. All right, so here's the formulas. Notice that in the formulas, we also need the IQR. Remember the IQR, I will do that right here, is equal to the Q3 minus the Q1. So that is equal to 78 minus 50, which gives us 28 as our IQR. So now we can plug it into our lower fence formula. Our Q1, remember, is 50 minus 1.5 times the IQR, which was 28. We just found that right over here. And so once you plug that into your calculator, let me try that out. We get 8. So our lower fence is 8. Let's also try our upper fence. So that would be Q3 plus 1.5 times our IQR. And then let me type that out. That gives us 120. Okay, so we have a lower fence of 8 and an upper fence of 120. So to figure out if there are any outliers, let's ask ourselves, are there any numbers less than 8? Okay, so any number less than 8. So taking a look at the data given to us over here, especially just focusing on the lower half, because if we're looking for small outliers, you're going to look at the lower half of data. Is there anything less than the number 8? Yes, 8 would appear somewhere there. The number 5 is outside of that lower fence. So let me write that outlier. And then let's figure out, is there anything bigger than our upper fence? So our upper fence is 120. 120 exists somewhere there. There's no data point bigger than 120. So our only outlier is the number 5. Okay, so now that we've actually calculated our outlier, there's actually a slightly different way to do our box and whisker plot. So because 5 is an outlier, you don't actually want to include it as part of this whisker. So let me highlight that to show you. We don't actually want to put this as our minimum. In fact, we want our new minimum to be the next smallest number, which would be 45. So I'm going to actually erase some of this. And I'm going to erase it all the way up to 45. I'm going to put 45 as my new minimum. Let me do that better. 45 as my new minimum. And then what do I do with the fact that there is an outlier at 5? I'm going to put a star there. And that star signifies that that 5 is an outlier and that the new minimum will be at the 45 mark. Okay, so now that we've calculated our outlier and we've put it into our new box and whisker plot, we can calculate the most appropriate measure of center and spread for each data set based on the data distribution. So with this, I actually want to refer to this sheet that I found, or not found, that I created and posted on the Google Classroom. So give me a moment while I pull that up. All right, so I couldn't pull it up on the Google Classroom. However, it is posted. Here's just the picture that will be posted, or that is posted. So it says, which is the better measure of center and spread? So you can start off by calculating the mean and median if you're given the numbers. However, if you're given a graph and you can see that it's skewed or symmetrical, then you can skip to this third step, where it says the data is symmetric and it says the data is skewed. So if you already know that it's skewed or symmetric, you can just skip over there. So if the data is symmetric, over here on the left side, if the data is symmetric, the better measure of center is the mean, and the better measure of spread is the standard deviation. If the data is skewed, the better measure of center is the median, and the better measure of spread is the interquartile range. So you can figure that out just by knowing if the data is symmetric or if it's skewed. And you can tell if it's symmetric or skewed based on the distribution, the picture of the distribution if you have it, or by calculating the mean and the median. So let's go back to our worksheet. All right, so now that we're back at our worksheet, let's take a look at our data distribution image that we have here. We know that we have an outlier, and we know that this half of the data looks a lot smaller than this half of the data. Therefore, we can tell that the shape is skewed. Specifically, this is skewed to the right side because more data is over here on the left. So the shape is skewed. It doesn't matter if it's left or right. For these purposes, we just want to know if it's skewed or if it's symmetric. So the shape is skewed. Therefore, the better measure of center is the median. And we already calculated the median earlier just by creating the box and whisker plot. The median is 65 right over there. So I'm just going to write 65 because we already calculated it. So we don't need to calculate it again. And the better measure of spread is IQR. interquartile range. And we already calculated that as well, right over here, where it says 28 in the top right corner. And so I'm just going to write IQR equals 28. And so luckily for us, we don't have to do any extra calculations here because it was a skewed graph. All right. Just so you know, if it was symmetric, then you would want the better measure of center to be the mean and the better measure of spread to be the standard deviation, your favorite calculation. All right, let's go on to number 2. So for number 2, the data are all of those things. So let's double check, first of all, that they are in order from smallest to biggest, and indeed they are. So once we know that they are, we can calculate our minimum, our Q1, our median, our Q3, and our maximum. Okay, so let's start off with our minimum and maximum, the easiest numbers. So our minimum is 40, maximum is 100. Now let's do the median. So to get our median, we're going to cross off the edge numbers until we get to the absolute center. And we have this number as our median. And then that splits it up into 2 halves. So the first half does not include the median, and the second half does not include the median, okay? So with our first half, I'm going to do that in green. This is our first half. We're going to cross off numbers until we get to the middle. So I'm going to cross them off the top. All right, there's 2 numbers in the middle. So what do we do with these 2 numbers? We're going to add them up and divide by 2. Okay, I guess I'll have space right underneath it. 47 plus 55 divided by 2. And that gives us 51. So our Q1 is 51. Let's do the same thing to our second half right over here. And let's cross it off. And we have 2 numbers in the middle. And so with these 2 numbers, let's add it together. 83 plus 92 and divide by 2. And we get 87.5. And so that will be our Q3. All right, with these 5 numbers, we're going to make our box and whisker plot. We might have to adjust it later just because there may be outliers, but let's draw our original box and whisker plot first. So we have our minimum at 40. We have our Q1 at 51. We have our median at 69. We have our Q3 at 87.5. We have our maximum at 100. So I like to draw the box first, but if you like, you can connect the minimum to the Q1 and then connect the maximum to the Q3, and then you can draw your boxes. It doesn't really matter what order you draw it in. I really don't. It doesn't matter. Okay, so here is our graph. I don't know about you, but it looks pretty symmetric to me. Let's first calculate if there are any outliers. So to calculate our outliers, we need to find our IQR. So I'm just going to do that over here. IQR is Q3 minus Q1. So remember our Q3 is 87.5 minus our Q1 is 51. And that gives us 36.5. Okay, and then let me write the formula for the lower fence and upper fence. Lower fence is Q1 minus 1.5 times the IQR. Oops. Upper fence is Q3 plus 1.5 times the IQR. Okay, let's plug it in. For Q1 minus 1.5 times the IQR, Q1 is 51 minus 1.5 times the IQR is 36.5. And let me type it in, and I get negative 3.75. Let's find our upper fence. So our upper fence is Q3, so 87.5 minus 1.5 times the IQR, which is 36.5. And that gives us 32.7. Oh, wait, sorry. This is supposed to be a plus. My bad. Do you see the plus sign? I wrote it wrong. So then I calculated it wrong. Let me fix my mistake. So we want 87.5 plus 1.5 times 36.5. And then that gives us 142.25. All right, sorry about that little mistake. It happens to everyone, but here we go. Now we have our lower fence and our upper fence. So let's take a look at our lower fence. It is negative 3.75. Are there any numbers in our data set lower than negative 3.75? Nope. So there's no small outliers. What about numbers larger than our upper fence? Are there any numbers larger than 142.25? Take a look. Nope. So there are no outliers. I'm just going to say that, no outliers. All right, so we don't have any outliers. Now the next step is to see if this is symmetric or skewed. So just looking at the graph, it looks very symmetric to me. Like it looks like the left side looks just like the right side. This is a symmetric graph, so I'm going to write that. The distribution is symmetric. Therefore, the better measure of center is the mean. All right, we need to calculate the mean. So to calculate the mean, what you need to do is take all the numbers and add them up and then divide by how many numbers there are. So we have the number 40 plus 47 plus 55 plus 63 plus 69 plus 75 plus 83 plus 92 plus 100, all divided by how many numbers are there? Let me count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, yeah, okay, 9 numbers. Let me calculate this and then I'll get back to you. All right, and so once you calculate this, you get that the mean is 69.3 repeating. And if you look, it is pretty similar to our median. So therefore, it is a symmetric data set. So this is our mean. And then also we need to find the better measure of spread. And that better measure of spread is the standard deviation. And so we need to calculate the standard deviation. Let me write it out. Remember this symbol? You don't have to remember what it's called. Just know that that is a symbol for standard deviation. It looks like a sideways B or a sideways 6, something like that. Okay, so what we're going to do is take every data point, for example, starting with the 40, and then I'm going to subtract the mean. I'm just going to subtract 69.3, okay? And we're going to square it. And to that, we are going to add the next data point, which is 47, minus the mean, which is 69.3, square it, and then we're going to do that again with the next data point, which is 55, minus the mean, and we're going to square it. Keep doing this, and I'm just going to pause the video. I'm going to write it all out, and then you can double check. Okay, so as you can see, I wrote out literally every single data point minus the mean squared. All divided by how many data points are there? There are 9 data points. So I'm going to divide it all by 9, and finally we're going to square root all of this. And then I'm going to write my answer over here because I don't have space, so let me type it in the calculator. So remember, don't type this on your phone's calculator. Please type this on like a Delta Math calculator or something like that. So I first type in all of this part just so that I don't do it in too many steps in the calculator at once. It just makes sure that I don't make a mistake. So when I type all of that in, I get 3 278.01. And still divided by 9 and it's in a square root. Then I'm going to divide by 9, the square root of 364.223 repeating. I'm going to take the square root of that, and I get 19.08 as my final standard deviation answer. Okay. And so let me just talk about standard deviation a little bit more. Every single time you take a data point minus the mean, you're literally finding the distance between every single data point and the center. This is the data point, this is the center. This is the data point, this is the center. You are squaring it so that you get a positive distance, and then you're going to add all these distances together. That's why it's all added together, all those data points minus the mean squared. You're adding all these positive distances together just so that you can find how spread out your data is, because you're literally finding how spread out every single data point is from the center. That is what the standard deviation calculates. That's why standard deviation is a measure of spread. The interquartile range is also a measure of spread because it literally measures how far apart your middle chunk of data is. So it measures your Q1 until the Q3, because literally the formula for IQR is Q3 minus Q1. So it literally just measures the width of this box. So it is also a measure of spread. So to figure out which one's the better measure of spread, if it is skewed, then the better measure of center is the median, and the better measure of spread is the IQR. If your data is symmetric, then the better measure of center is the mean, and the better measure of spread is the standard deviation. However, both are ways to measure the center and standard deviation. It just depends on if the shape is skewed or symmetric. All right, so if you have any questions, let me know. Other than that, your task is just to do 1 through 6, okay? So it's not that much, just 1 through 6. Let me know if you have any questions.